Okay, we are looking at question 8 on the 2015 Year 9 exam paper. This question, it's very important to read all of the stuff at the start of the question before you attempt it. Okay, lots of people, I think, didn't do that and it really let them down. So, we've got a special flask for storing liquid oxygen in the laboratory for use in dangerous experiments. Oxygen as a liquid boils at -196 degrees C. Notice that it says it boils at that temperature. Room temperature is 20 degrees C, therefore liquid oxygen will boil at room temperature. So given the chance, it will boil. Okay, that's very important later on. Jenny would like to stop thermal energy from outside the flask from getting to the liquid oxygen, causing it to evaporate. Okay, so we're going to try and prevent energy transfer to the liquid oxygen. Okay, so the question is all about trying to stop thermal energy getting to the liquid oxygen rather than what you're used to, where a vacuum flask is being used to prevent thermal energy escaping a hot liquid or a hot gas. So we've got the cross-section of the flask. Explain how the shiny surfaces, okay, so the shiny surfaces that are on the insides of both the inner and the outer walls, reduce the thermal energy transferred to the liquid, okay, to the liquid oxygen from the laboratory. We're not worried about trying to reflect thermal energy back in. If anything, that means that wouldn't help us. And there's no such thing as cold energy. It's not a real thing. Okay, so you can't reflect cold back into the liquid oxygen. Okay, that is bad physics. All we can do here is try to prevent thermal energy entering and reaching the liquid oxygen. Now, shiny surfaces are good reflectors. Okay, are good reflectors. Okay, that is to say they are also poor absorbers of radiation, and we need to be specific that we're talking about radiation or radiant heat as opposed to conduction and convection. Okay, shiny surfaces won't prevent conduction and convection. In fact, most shiny surfaces are metals and are very good conductors. But they are good reflectors of radiation, okay, preventing the radiation from the lab reaching the liquid oxygen. Okay, the surfaces reflect the radiation back. That's what we need to be saying. Okay? Essentially, if you said the shiny surfaces reflect the radiation back away from the liquid oxygen, you would get both the marks there. Okay? It's also true to say that the shiny surfaces tend to be poor emitters, and sometimes that would help you gain the marks, but this is the really key point, that the shiny surface reflects the radiation. Okay, those are the 2 marks. Now, moving on to the next part. Explain how the vacuum, okay, that we have between the glass walls reduces the thermal energy transferred to the liquid oxygen from the laboratory. Notice it says explain. Okay, so we have to explain it fully. Okay, so conduction and convection both require particles. Okay, or a medium to occur. That's because conduction needs the particles to be able to collide with each other to transfer energy from one to another, and convection requires the particles to be able to move around. Okay, so hot air rising, so the hot air rises because it's been heated up and moves faster and therefore is less dense, and that hot air rises. A vacuum, let's spell that right, V-A-C-W, so U-U-M. So a vacuum has no particles hence conduction and convection cannot occur. Now, Jenny's flask does not have a lid when holding liquid oxygen. Suggest why a lid is not needed. Now, this was a really tricky question, very difficult one, but it requires this knowledge from the first part of the question that because of the fact that we have a boiling point of minus 196 degrees C, some of the liquid oxygen is going to evaporate. Okay? That means that if we've got our flask, okay, I have a rough sketch, and our liquid oxygen here, some of this liquid oxygen is going to evaporate and form a it's going to form and it's going to be just above the liquid oxygen. Now, the liquid oxygen, the oxygen vapor is very cold and hence will not rise. Okay, we know that hot air and hot gases rise above cooler ones, okay, but the oxygen vapor is very cold, okay, much colder than the air surrounding it, so it will not rise. Hence, it will sit above the liquid oxygen forming a sort of lid. Okay. In essence, okay, even without talking about the fact that the liquid oxygen evaporates, you can get the marks by saying, okay, hot air rises and will not fall, hence the air/vapor. Okay, if you didn't know about the vapor and you just said air, that's okay. The air or vapor next to the liquid oxygen will be cold and hence convection currents will not be set up. Okay, this, as 1 Year 9 actually commented, is called the Leaden frost effect. Very well done that was Jean Ribot, who managed to note that in the exam, very impressive. So the final part, in fact most flasks like Jenny's do have a lid, but it's very loose fitting. Explain why a tight fitting lid would be dangerous. Well, that is because, okay, as the oxygen evaporates, and it will, you can't prevent all heat transfer, so some of it will, okay, the gas expands because gases are far less dense than the liquids, and pressure increases. So an explosion could occur. And that is your lot.